So, uh, yeah, I mean, I'm just going to talk about a small introduction to game theory, like how just maybe play a few games among ourselves, and I'm going to define payoffs strategies, just a normal jargon for the games, and I'm also I'm just going to start with.
Are you doing
You have? I think there's photo. So I'm just going to start with something called as a grade game. Actually, these are all games and all the material, right, are from. I was watching some lectures by Yale professor called Professor Polak. So all these games are like part of the course also. If you like, it's really interesting. And then I'm just going to some just basic definitions, like the normal terms used in this particular game, in this particular subject, and we're going to talk about prisoner's dilemma. This is another very common game. I mean, used in basics of game theory, just to understand what's going on, and we'll also try looking at, and if we do have time, we'll try looking at Nash Equilibrium, some mixed strategy, and some mixed strategy games. Nash Equilibrium, which is one of the very important topics of game theory, and we'll also look at very applications, like how game theory can be applied to specifically communications, like networks. So this is going to be how the presentation is, and so let's start with a very simple game. So let's see. Let's say you have two options, right? Alpha and beta. Okay. So this is just individual. Like you have to think about it on your own. So let's say you have two choices, alpha and beta, and let's say that you pick alpha, and another person in this group picks alpha, right? You get a grade of B minus. Okay. So let's say you pick alpha, the other person picks alpha, right? The pair. Let's say you're paired with somebody at random in this particular group. So you pick alpha, the other person picks alpha, you get B minus. Okay. You pick alpha, the other person picks beta, you get A. You get an A grade. Okay?
Those two persons must be a pair or randomly?
Random. They could be anybody. It could be Amin, it could be B, it could be anybody.
So they must be a pair, right? Those two.
No, just think about it. Just like,
how many people then?
Huh? Just this group. Just think about it. It could be anybody from the group. Do you get it?
So suppose we have three people, then only alpha and beta, then one is alpha.
No, that's fine. Let's say you're picked with, say, Amin, right? Let's say there are 6 people here, right? Because there are 3 pairs. Just think about that. Okay, just some other guy, or it could be me also. Okay, so you pick alpha, and if I also pick alpha, you get B minus. You pick alpha, I pick beta, you get A, right? And you pick beta, and I pick alpha, right? You get C. Okay, and you pick beta, and I pick beta, you get B plus. Okay, so which one would you pick? Or do you get the question?
Yeah. Beta. Alpha. So it's grading me, not you. Like you don't get anything. This is the grade that I'm gonna get.
Yeah, yeah.
Yeah, I would pick alpha all the time.
And you said beta.
Beta, yeah.
Alpha. Because with alpha, if you get A or B minus, that's still good. But with B plus and C, that's like really bad either way.
But I think everybody try to pick the beta. The whole game is better than everyone try to get alpha.
Really?
Yeah.
I think alpha you have a better chance.
Because if you pick
Well,
alpha,
here's one thing that I'm not understanding completely right.
Okay.
So it's my turn. Let's say
Right.
I'm here, me and Schwan.
Right.
And it's
You
my.
don't know what he picks. You
Alright,
what
I don't.
Sean picks.
Yeah, exactly. But I'm gonna start the or I'm gonna pick alpha.
Okay.
Then he's gonna pick something, but only me is gonna being is being graded, not him. Is that? Or both are being graded?
Both are being graded.
Okay.
In that case, probably if you think you are going to pick alpha, he wants to pick alpha also, you took up B minus. But if you think he's graded also, then you should pick up beta because he's trying to.
So if it doesn't matter, then why is there alpha beta and then beta alpha?
What do you
If the sequence doesn't matter, who picks what first or like?
first one is for you, second one is for your.
For my partner. So
Yeah.
by why? So and the grade is for both, but you start from me, not from.
No, it doesn't matter. I mean, it's just your, okay, think on your terms.
Oh,
The square is mine. A is mine.
Yeah, yeah. So, okay,
so
let's,
if the
okay.
sequence doesn't matter, like okay, alpha beta, and then we'll switch and we'll
So-
get
so this, okay,
A. No?
so I think
Maybe I'm not
at
understanding.
least most people, right? Most people in the world, right? It's shown that 70% of actual people pick alpha, then beta, right? So let's say that this is a matrix, right? Okay, so this is player 1. Okay, this is player 2. Right? So if player 1 picks alpha and player 2 picks alpha, player 1 gets
B minus.
B minus, right? And player 2 gets A minus, right?
Yeah.
Right. So when player 1 picks alpha, player 2 picks beta, right? So player 1 picks alpha, player 2 picks beta. He gets A.
B and C.
And what is this one?
C.
C. Okay. So what is beta alpha now?
C and A.
A. B plus B
B
plus.
plus.
So this is what is called, like, in this very simple game, right? This is what is called the payoff matrix. Okay. So these are the strategies you pick. I mean, you could either pick alpha or you pick beta. Okay. And these are the payoffs, the actual payoffs. So this could be like, well, when you quantify it, this could be what, a 3.25. Yeah, B minus is 3.25 if you quantify it. A is 4, so you get different payoffs for different choices you make. Do you have?
No, I'm just looking at.
Okay. So let's say we're here, right? So Mohammed was actually kind of right. I mean, you were right when you tried to reason out what your pick was. So no matter what the other person picks, right, you will choose alpha because it gives you a payoff, a higher payoff than
To me, not to them.
Right, right.
But the whole,
But see, that's.
whole score is better for the beta.
Yeah, but you're not certain that So every player who's rational, right, think of maximizing their own payoffs.
Exactly, but here's the thing that I was trying to get to know is that first you said if alpha alpha then both get B minus, and if alpha beta then both get A, and then if beta alpha both get C according to me. So now it's not actually what I thought it was. So it's so if I pick alpha, he picks beta, we don't both get A. I get A, he gets C.
Yeah.
I thought it's like both get A.
That's what I said. Yeah, you said.
Doesn't make sense.
I said both
Yeah,
get
no,
Yeah, you
no,
did.
You said you.
Yeah, which made me a little confused. Anyway, it's okay. Now I see.
Okay. So
I'll
this
still
is
go with alpha.
I mean,
get.
But Amin's case is right when what?
I'll get him to fail.
He is good. He is okay.
When Amin's case is right when there is your case is right when there is a game like like a cooperation game, like a cooperative game where 2-3 players actually form some sort of a group and then try to maximize their payoffs. Now this is when you don't know what the other person chooses, so you always go with what your this thing is. I mean, what your best payoff is. So here, right? Let's just compare. So if player 2 chooses alpha, right? You would get so you would either get B minus or you would get C if you choose alpha or beta. And player 2, if he chooses, so this is greater, right? So if player 2 chooses beta, you would either get A or B plus. So you would choose this one again. So this particular strategy, right? You would basically take this into account no matter what the other person chooses, right? So this is what is called dominated strategy. I mean dominating strategy, right? So okay, actually this is a strictly dominating strategy, meaning you strictly do better than the other strategy, right? So let's say that let's say I'm getting into the details here, but let's say instead of B plus, right? Let's say you get an A here in this particular thing. Okay, so when the other person, player 2, chooses beta, right? You would basically have the same payoffs whether you choose alpha or beta. So this particular thing is weakly dominating. So this particular strategy is weakly dominating the strategy of picking beta. So well, just to give you you may be wondering how this is useful in how this is going to be useful in maybe communications or something.
One second. The weakly dominating strategy.
It's the whole thing. Sorry. It's weakly dominating. This particular strategy is weakly dominating this strategy. Did I make it clear?
Well, then the strictly dominating strategy is that.
No, the strictly dominating strategy becomes the weakly dominating strategy.
Oh. What? Really?
Yeah.
Why?
So, okay. So, what is a dominating strategy? I mean,
so that you're probably gonna win.
Right. So this is so a dominating strategy, right? It could either be strictly dominating or a weakly dominating strategy. Okay. So strictly dominating is no matter what the other options are.
Okay. So
Because of I'm
don't throw that.
Yeah. I just wanted to say because of this particular strategy became weakly
So the
dominating.
strategy we're still talking about alpha.
Yeah, we're still talking about
only
alpha, and this is alpha here. Alpha is dominating, and it is in the previous case it was strictly dominating. In this particular case, when it's greater than or equal to, it's weakly dominating. So,
Question:
yeah.
If in the upright instead of A we have, for example, B plus.
Yeah.
Yeah.
Okay.
Again, is strictly.
No, neither strategy is strictly dominating
Because the
or
average is
dominated.
B and
So you could pick either strategy. For example, if let's say for example, he's going to pick alpha, right, with probability 0.9, beta with probability 0.1, right? So with this particular strategy, let's say you more or less when alpha is for alpha, right, your best response would be B minus. Okay. If the belief is beta, your best response would be A. So this is best response. You get the meaning of best response now.
Is that Is it 0.9 or it's not 0.9?
Okay, I mean, well, it's not 0.9 anyway. It's the belief. So okay, just can you use the book?
Yeah, sure.
So
Can you see?
I'm sorry, I think I confused you with the properties. Don't worry about the properties now. Okay, so for player 2 picking alpha, right? The best response for player 1 is picking alpha.
Yep.
Okay? So for the same thing, player 2 picking beta, the best response is beta. So neither strategy is dominated or dominating. Okay. So now we know what a dominating strategy is. We know what a dominated strategy is. I mean, the one that's dominated is called the dominated strategy.
So can we enforce a strategy on the other? Like, can I like tell him to always choose beta?
It's a game. That's why.
Can you pick him and choose beta?
Like, if we're playing together,
you could
we're
believe-
trying to like I can cheat this, but like maybe we don't know.
No, but the
really.
payoffs are already defined. So I mean, if okay, so when would it be a case when he always chooses beta? Let's say okay, when would be a case?
See, game there are kind of two categories. One is competitive, another one is collaborative. So if you are doing collaborative game,
No, let's talk about competitive. Okay, because collaborative, I mean, I think it's a bit more thing. Let's talk about
exactly.
competitive.
And that's what, if it's collaborative, this doesn't make sense. But if it's competitive, like we're trying to beat one another, then yeah, I'm trying to get,
Yeah,
he's
so-
trying to get me down.
So when would you think like he's always going to choose beta?
He's not gonna always choose beta.
I mean, okay, he's going to choose some strategy, not this one. Don't worry about this one. So when do you think he's going to choose some particular strategy?
Well,
What we have defined.
when it looks like it's more dominating than the other.
Exactly. So it's going to be either strictly or weakly dominating strategy, right? So that's when he's going to choose beta always.
Sure.
So this is only in competitive. Like let's talk about competitive games. And so we now know what are strictly dominating, weakly dominating, dominated strategies. So we'll just go for some, just formal definitions, formal notations. So we'll say like SI to be the strategy for player I, and so we'll also SI to be a set of all strategies of player I, and
Is this a different S?
and we'll say S minus I to be any choice for all players except player I. Okay, so this is just normal definitions which we made.
It's a combination.
Sorry? No, this is any choice or any strategy.
I mean, it's for all players, so it's a set.
Yeah, this is a set. But we don't, okay, we are not concerned about what other strategies. It's just the other players' strategies as one. We just consider that. We are not concerned about each and every strategy of the other players, right? Okay. So we have this one. So we'll also define the payoffs here. So U1 of beta, right, is basically the payoff, and U1 of beta, let's say beta comma beta, for example, right? U1 of beta is basically like A here. You know that, right? For example.
It's the subscript to the one.
U1?
No, it should be beta 1 and beta 2 our
U1 of beta comma beta. Okay, this is player 1.
Yeah.
This is always player 1. This is always player 2.
Oh,
So U1 of beta comma beta, right? And this is the payoff for the first player. So if this is U2 of beta comma beta, right? This will be
B plus.
B plus. Okay? This would be B plus. Okay? So okay. So we'll then go on to another very common game. It's called the prisoner's dilemma.
we know the payoff function we want to maximum.
We'll know the payoff function that we want to maximize.
What's the useful one? That's payoff function. How do we use that?
Which one?
The payoff function. You
Okay.
just give us the payoff function.
So okay, you would have to derive the payoff function. I mean, for different scenarios, there will be different payoff functions, right? So in this particular case, you didn't have a function; you had quantified values here. But for, let's say, there's a firm who has, who needs to set up their prices, right? You would basically start with, let's say, how would you derive the payoff function? It would be the total revenue minus the cost, or it could be like, you would have to derive the payoff functions for each and every scenario, or each and every, entity. So it would be different for different cases,
Yeah.
or for different games.
What's our goal? Our goal is to try to maximize the payoff function or minimize.
Our goal is to basically, in games, okay, what is your goal in games? You basically try to get your given payoff, your payoff given a set of constraints, right? So your goal would be, to maximize your payoff for given set of rules for the game, right? So this, you would have to keep this in mind. So you would basically have to derive maximum payoff given if you have another player in the game, given what he chooses. Okay? Do you
So the payoff function depends on the current state. You have different states.
you have different strategies. Well, you could call it, do you have different states?
But if you think about a company, due to different financial situation or market situation, they might in different state, and in different state you might have different payoff function. And then you have to figure out the strategy for the current state.
That would be their particular strategy, right?
But the strategy
Is, I guess that he will be limited to a static game. Like, so this is actually only static. So there's no state. Like all the strategy are fixed for the movie. Just assuming a very simple, like basically the simple answer is no state.
okay.
at a given time.
It's not like playing a chess, you have a different combination
No,
of...
at the moment, no. Not yet. But if we go to dynamic game, later on, maybe probably not today, then that will be stay.
So what were we? Okay, so let's say there is, like there are two prisoners in this game. Let's say that there are two prisoners, and well, there are two suspects actually. Okay, so if they're okay, let's say they're being interrogated by the police, and one okay, they cooperate or first let's see.
Whoa, 10 years.
Okay, so if one remains silent, right?
Yeah.
And the other remains silent, like they don't confess or they don't do anything at all. Okay, they just remain silent. Each serve 6 months.
Can you put A and B? So A is the
Okay. Oh. Okay. So A remains silent and B also remains silent. They don't confess or they don't betray each other. I mean, betray in this particular sense is the other guy did the mistake or other guy did the stealing. Okay. So each serves 6 months. Okay. So if A remains silent and B betrays, right? So A gets 10 years. Okay, and B goes free. So can you envision that time? And it's a symmetric one. So so A gets free and if both betray, right? Each serve 5 years. Okay. So this is can you? I mean, okay. So let me put this in really like a. So.
Well, depends on the detective.
Okay. So. So basically they get like a payoff of 3. Okay, so it's more or less when you look at this you could doesn't it seem like this, can you understand what's going on?
Yeah, but why the numbers? Why those numbers?
Just okay. So it's just each 6 months is just some random payoff. Like the 10 years gets the highest payoff.
Okay, so it's kind of like equal if both.
It's just proportional to those.
And they're opposite if both do opposite.
Right. Okay. So is there any dominating weekly strictly? Are you sure?
If well, a lot of pressure, man. It's like it's either 6 months, 5 years, or 10.
How free?
Yeah, free.
So
Yeah, count on other people to be.
well,
innocent.
I can give you. There is one dominating strategy here. I can
There
give
is?
you, yeah, there is a dominating strategy.
Is it weekly? It's probably very weekly dominated.
It's strictly dominating.
What?
Yeah.
Think math.
No. What's a strategy?
Both doing the
Being
same
silent
thing.
or betraying, right?
Both
So-
doing the same thing.
No, there can be a strategy. Both doing the same thing is a choice, right? It's a square here. Let's say both doing the
So
same thing
both
is
being
S.
silent is one strategy?
No, being silent
Being silent.
or betraying. That's the strategy.
Exactly.
Because so okay, let's say I'm player 1. I can either be silent or I can betray, right? Or your player B, right? You could be silent or you could
In
betray.
this matrix, if you choose silent and then your opponent choose betray, then you get 0.
Irrespective of if I choose silent and the opponent chooses betray.
Yeah, you get 0.
Yeah.
You gain nothing. They won. They got 5 points and free.
It's competitive game.
You get 10 years in jail, man. So you don't get a payoff at all. Right? I mean, you get the minimum payoff. It's basically that. It's supposed to mean that.
I'm a very convincing person.
So okay, can you understand what's going on? I mean, in this particular game, I'm trying to translate this.
Yeah, but-
yeah.
The B betrays
This,
better.
I'm sorry.
Betrays better.
Yeah, because it's free.
So how do you? I mean, can you reason out?
It's, it's a
I see.
competition game or it's a
Competitive.
competitive.
Okay.
Yeah.
Here's the thing, it's not strictly dominating, it's weakly, it's very weakly dominating because in both cases, the
What is
the
weakly dominating? What is a weakly dominating strategy?
It's a strategy dominating. If you betray, I think it's better.
Betray always get better.
Maybe you are free or it's
5 years.
hard.
Yeah, it's either 3 or 5 years.
Yeah.
That's
No,
better than
it's
6
free
months
or
or
Yeah,
not.
so
Maybe
can
you
you
win or it's a tie game. But if you be silent, it's tie or lose.
Exactly. 10 years, man.
Let's talk about this particular matrix now. I mean, reason it out here in this particular game.
And this part, I agree with that. I mean, betray is dominating. It's like highly dominating because it's either you get out or you both stay in. So like if it's competitive that I'm gonna stay 5 years, but you also are gonna stay.
Yeah.
Or I'm gonna kill you, you're gonna stay for 10 years and I'm out. Of course I'm gonna betray.
Right. So that's actually the answer. That's the dominating strategy. I
You
mean,
just said silent.
no. Did I say silent?
Yeah.
No.
No.
Okay.
I'm hearing voices.
Everybody is okay. Maybe we can come back and check. Like,
Okay, let's check.
Okay, so let's just if player 2, right, chooses silent, okay, I either get a payoff of 3 and I get a payoff of 5, right? If he chooses silent. But if he chooses betray, right, I get a payoff of 0 and I get a payoff of 1. Right?
Well, if you behave in a good manner, you might get some.
5 is more than 3 and 1 more than 0.
Right? So you would basically choose this particular one. I'm trying to do it.
I have a question. So in this game, what if like some new conditions are introduced, like that would affect the things over there? Like
So-
can you introduce other conditions that, like, okay, it's 5 years, but if you're if you're acting good, then it'll be 3 years. No, I'm serious. Like this is an example, just a condition, but like,
But, yeah, that's-
what other, like, you know, can you introduce some conditions that would affect the whole, you know, scheme and
Okay, if you change the rules, it's a different game. So there are different payoffs.
just the
in that
condition, not
particular
the
game.
rules? Okay.
So I
Never
mean,
mind.
we're just talking about this particular game.
I was thinking about.
Good idea.
I think about conditions.
Okay, so do you get it? And so there is.
I don't want to play.
So you choose betray, right? So let's say your prisoner 1, you choose betray, the other prisoner also chooses betray here. So there is something which is common between both, right? So this is basically your best response, taking into account the other player's best response, right? The other player's best response is betray. And with that in mind, right, you choose your particular best response here.
Okay, here's a better example of what I meant about conditions. Do I know the other person or not?
You don't know.
There's no
You just know he's
no
rational.
prior. There's nothing.
You just know he's a rational guy. I mean, he
Okay.
thinks like
So there's no connection between the two before, like there's no prior information about like both. Like oh, okay, I know him. Both of us are gonna be silent or something.
No, for now he's a rational player. I mean, he's the same as you. Like there are no personal choices, nothing. So he thinks like to maximize his own payoff.
Sure.
And that's the rules of the game.
Well, if he's rational, he can choose to be silent, and he thinks probably you are as rational as he is. He can choose silent also. You took at 6 instead of 2.
But he's just trying to maximize his payoff.
Yeah.
But rational doesn't necessarily mean greedy.
I look and I see that Bailey playing against me, even if I don't know anything about it, just in trade.
Well, okay.
I mean, if you think this rational and do it that rational way, then
Of course
that's
he's
just
why don't you
right.
take advantage of him?
Ooh. True.
If he is silent, why don't you just betray it? Then you don't even need to go for 6 months.
Well, I mean, if he can imagine you are such kind of people, then he will just betray you.
Yeah, but
Exactly.
Right?
Yeah,
Both
that's
of you
what
guys are
the
going to
game is
betray.
about, right?
I get the point, but I think that's the not only thing you can do in some case.
okay, you know what? We're getting too philosophical about this. We understand.
I get that also, but I'm thinking about are there any other situation you can think of?
Where he chooses silent and silent.
Yeah, because this is so obvious. Everyone can understand you choose betray is better. But I'm thinking about if you have any situation, you can make the choice to be silent instead of betray. So I'm thinking about brainstorming. It's not.
Yeah, definitely there is, but then like, it will be a different game. So you have a different matrix, right? Just
You get different payoffs for this particular.
Like they didn't go to Smallville and get those 2 people who are like really kind. Like they went to the streets and got 2 crooks.
If you think less about yourself and try to think a bit more to other people, you might end up getting more. So this is kind of. Yeah, I'm not trying to say this is wrong, but
I know what you're saying, but given this particular, given this particular uncertainty, or given that everybody is like, what you're saying is true. Okay, what you're saying is more collaboration would obviously help, that we know of. But given that you don't know the other person, you don't know what he is. He's just trying to This is the simplest way you can at least approach a game logically.
yeah, I totally understand this. I have no problem of this. I'm trying to think about the implication of this model. If I try to protect myself and being bad to you, then you can do the same thing to me. Then things only goes to a worse direction.
this is a static game, so you only play it once. So if you make a dynamic game, you put states there, then it will be different.
Okay.
If you build a relationship, then it's not a static game anymore.
I saw dynamic.
I'll just, okay, there are more things here, but I think I'll just talk about the problem that Sam wanted me to actually do it here. So where's the thing? Okay, so let's say we're just going to solve another game right now. So,
But by the way, I guess you at least want to say what's Nash Equilibrium.
Okay. Yeah. Okay. Do you want me to say it now or after the problem? Because the problem doesn't.
It's fine.
It's fine.
Yeah, okay, maybe then we could have these three of us.
Okay, so take another game. Okay, so in this particular game, right, we saw that Betray was the dominating strategy. Okay, so this. Okay, let's say Betray is when you choose Betray and the other person chooses Betray, right? I mean there is this intersection point, right? When both choose Betray, this is basically what can be termed as like a Nash equilibrium. So a Nash equilibrium, like the formal definition is, it's basically a way of predicting the outcome of a game, right? With multiple players and simultaneous moves. Okay, and it's basically like you can think of it as your particular strategy given the best response of another person's strategy, right? Okay, do you get it? So you have this particular payoff matrix. Okay, you know that what is going to be my best response to this particular player too, and vice versa. So you arrive at a particular S1 star, S2 star. In this case, it's beta comma beta, right? So this particular thing is the Nash strategy. I mean Nash equilibrium. Okay. So let's just take another like a. Let's take a very simple game here. Okay. So what do you think is like the Nash equilibrium here? I mean, and a game can contain more than one Nash equilibrium.
So the first one was
1, 1 and 0, 0, right?
What?
Yeah. So it's basically okay. Look.
It's not 1, 1.
No, 1, 1 and 0, 0. So let's go step by step. Okay.
Do you mean 1, 1, 0, 0? You mean alpha, alpha, and beta, beta? Like both doing the same thing?
Yeah. Alpha, alpha, and beta, beta. Okay. So let's say that given my belief that this particular player 2 chooses alpha, okay, which one would give me the best payoff?
given what?
The best payoff. I mean,
Alpha. Alpha.
the maximum payoff.
Alpha.
Given my belief that player 2 chooses alpha, what would be my thing? I mean, which one would I choose, alpha or beta? Alpha, right? 1 is greater than 0.
Giving your belief.
That player 2 chooses alpha. What would be my best response?
Given that 1 is good, better than 0.
Do you have same given condition in this graph?
Yeah. So given my in this particular one?
Yeah.
Okay. Given my belief that prisoner B chooses silent, which is my best?
So is the assumption is your opponent will choose the same strategy as you do?
Will choose the same logic as I do, not the same strategy. Do you get it? So you get 1 here. I mean, you choose alpha here, given he chooses this.
So in the previous case, A will choose B, right?
Exactly. Yeah, A will choose B. Yeah. Right? And this particular thing, right? For the belief that player 2 chooses beta now, what would be the best?
Anything.
Choosing alpha and beta would be the same, right? So you could basically say that A is weakly dominating against B, right? So it could be either of these two.
Alpha or beta or A or B. You say A is.
I'm sorry, alpha is strictly dominating against beta.
Strictly.
Weakly. It's weakly dominating
Yeah,
against
exactly.
beta.
See? Go back to the.
No, I think first time Siddharth said true. It's weakly dominating.
Weakly dominating. Alpha is weakly dominating against beta.
Alpha is me.
Strictly.
You just have a.
Weakly, yeah, weakly. So, okay, look, one is greater than 0.
Choosing alpha all the time is a strategy that's weakly dominating over choosing beta all the time. Do you get it? So you're player 1, choosing alpha all the time
Yeah.
is weakly dominating than choosing beta all the time. Look at the rows. See? Because you have a chance to get a 1 with
1
alpha.
greater than 0 and 0 greater than equal to 0. Equal to. Okay? So you could say that this is weakly dominating. So
become the alphas as well.
it's just
So you will always choose alpha.
you'll always choose alpha.
Yeah. So then by the same logic, your opponent will choose alpha also. So they will all choose alpha and alpha.
Yes.
So that.
But there is
So that should be the Nash equilibrium.
that's the Nash equilibrium here. But there is a very very weak Nash equilibrium at 0, 0.
Why?
You want to say beta comma beta.
Okay, beta comma beta.
But
You don't have to choose beta.
yeah, exactly.
So I guess that you want to be more precise when you say the Nash equilibrium. Actually, the Nash equilibrium is very simple. It's just like consider all the other players are not changing their strategy for the moment, and you have the strategy that you are using at the moment. That particular point right now is the Nash equilibrium. If my current strategy won't, if I change my current strategy, I won't get better payoff. I'm saying for all the other players as well.
Does that mean you are using the best strategy right now?
Yes, you can say that at this stage. So therefore, like for beta, like if you assume the other players, like for example B is not changing its strategy, then I'm already yes.
This means you know B's strategy.
Yes. All the time we know everyone's strategy. Of course, you don't know the strategy. Okay, yeah. Okay.
Suppose you
Suppose, and then you have a chance to change your strategy. Let's say, like at the same time.
This game is a little bit confusing. Is there a better example? Because like in
No,
this game,
this one is okay.
is it okay? Why then?
Let's say we are stuck at beta for the moment.
All right.
And let's say I'm A and someone else is B, and B is choosing beta now, and then A, I have a choice in the next one, let's say, do the same thing, and then like the Nash equilibrium, or like at this stage, beta is a Nash equilibrium, because if I assume the other guys is not changing his strategy, and no matter what other strategies I'm choosing, I'm not getting a better payoff.
In the first place, why do you choose beta at the first place?
Oh, okay. Let's just think of somehow, I don't know, like your philosophical reason, whatever, that you start. The Nash equilibrium doesn't mean that you get the Pareto optimum or whatever, but it's just a equilibrium point that like if only one player going to move away from that equilibrium, that player will get worse or like not better off.
Oh, okay.
Yeah.
See, that's why, like.
Yeah. So therefore, if we already a beta, neither of the player have the incentive to move away from that strategy.
It's actually, I mean, when you compare it to this one, it's really weak. I mean, there is very big incentive to move away from that particular equilibrium. When you compare it to this one, this is more stable than this one. Do you?
Yeah, exactly. But,
Yes,
but is this a competitive game still?
Yes.
Because this shows no competitiveness, because either way you're not going to do anything changing or like this game. Like,
Okay, I have
that's why
question.
like it'd be a
If-
shift in
if
the numbers.
1-1 shift, for example, 1 down, and we have 0-0-0-0
Yeah,
and
I
1-1
may
and 0-0. What was the equilibrium?
I'm sorry.
Yeah, we changed the two.
Here.
Yeah.
Okay.
0-0, 0-0, 1-1, 0-0.
In this case, beta alpha and alpha beta are the Nash equilibrium. That means the lower black corner and the upper white corner are the Nash equilibrium.
These two.
So what did you just do?
Okay. So there is another. Okay. Given he chooses alpha, right? Believe that he chooses alpha. I could either take 0 or 1. I prefer 1. Okay. So this is 1 here. Given he chooses this one, I could take either of these two. Given the belief that he chooses beta, right? These two. Okay. And then this is the same for player 2. Okay. I could take either of these two. Okay. So there is a point where these two, it's basically the point where both the best response is made. Okay, so it is one is here and here, this one, where both the best response, both best responses. Made.
So Nash equilibrium fails if you cannot find.
Is it?
I
Did I
don't want you to say best response because it's not the best one in this case. Like for example, when we choose alpha beta, like the upper right corner, therefore like I would prefer the terminology or like the interpretation that you are at that equilibrium now, like you have that strategy now, and then like assuming all the others are not changing their strategy, and then I don't have incentive.
I mean, it's the best response when you believe.
Well, it's not exactly necessarily the best, right? I mean, like, you are not getting better when you move away from your strategy. But that current strategy, like in this case, both of them are.
That's a local maximum.
Yeah, or like, to call it maximum is just flat.
It's wrong.
No, I mean that if we don't know about the second, another player, maybe that one was one.
Yeah, you won't get better.
We know that it's same.
You won't get better. So therefore, you have no incentive to change your strategy. In this case, it's basically you don't get better, right?
Yeah,
Like if you are in alpha beta,
No, it's still.
and the first
He
player,
would already go for
having
beta.
alpha, right?
Yeah.
He wouldn't go for
Even I swap to beta, I'm not
he
getting
wouldn't go
better.
here at all.
So
He would
why
always go
do I want to swap?
this particular.
There's no
option.
incentive for me to change that.
I mean,
No, yeah, my question
If
is
I- if
for
I
the
get-
second half. Why you choose this one? We choose this one.
no, but okay. So, player 1 will. Let's say player 2 will choose alpha here. Why would? I mean, what incentive would we have to go for beta? He would choose only alpha here.
Yeah.
So, and this guy will choose beta here, right? So why should they go to wait? Am I asking you a question? Why should they go to beta comma beta? Right? Am I explaining it?
Another question. If we have 2 0 0 0 1 1 0 2, what
Another
happens?
game?
Yeah.
Okay.
2 0 0 0 1 1 0 2. These two.
Right. I mean, correct me if I'm wrong.
Yeah.
These two. I'm wrong? I mean,
Yeah.
these.
Wait,
So,
the low, yeah, I think it's fine.
And if we change, for example, 0 0 to 1 1.
so I mean, do you get what I'm trying to do?
Yeah.
Okay.
I want to have some more
Oh,
example
okay.
to understand. And if we change 0 0 to 1 1,
This one?
yeah.
And the lower counter doesn't work anymore.
This particular payoff like won't have any effect, right?
No, then the lower counter.
Oh, no, I'm
yeah,
sorry.
it doesn't
One
work
second, one
anymore.
second.
Yeah.
So, given I would choose this one, and
Not the upper one. I mean the
so
lower one.
I would choose this one. So this is no longer a Nash.
Yeah, actually, upper one doesn't work.
Yeah, this is no longer a Nash equilibrium. Did you get what? This is no longer a Nash equilibrium because he has a tendency to move to beta rather than be at alpha. He has a better incentive to move to beta rather than be at 0. So okay, so the easiest, I'll tell you an easy way to find Nash equilibrium. Right? When you are in the, take a particular strategy. Say you believe in this particular strategy. See what kind of maximum payoff you get. So this is you get 2. Here, okay. For this particular strategy, say player 2 plays beta, what do you get? You get this particular highest. Okay. So do the same thing for another one.
Okay, you mess up. That's the payoff for the first player. You should look at the 0 and 1.
No, 1 second. So 2 and 1 I get.
Yeah, you go
This
down or. I mean, when you say 2 and
No,
1,
this is
you want
1
to
and
say-
1. 1 and 1 is the max.
Yeah, yes, but you want to say like 2 and 1 figure. Because that first one is the payoff of the. This is the payoff of the first.
Yeah.
First
Oh, no,
payoff,
I'm sorry.
and
This one.
This
Yeah.
one and this one. Or you wanted to work on
This one. Yeah. I'm sorry. Sorry. Can I repeat it again? Okay. So I get a higher payoff with 2, right? And player 2 gets a higher payoff with. Is that okay? And then, like it's the same thing this way. So I get a higher payoff with 1. Right? And so this is yeah. This is
This one is Nash equilibrium,
No, that's no less.
but
Oh, wait a second. Yes. Oh, I don't think one is see, this one, yeah, this one,
yeah.
that one is Nash equilibrium.
and you explain it again.
Okay.
Okay, let's say just you can just go directly to the one there, maybe, right? The one there, and then you see like the upper right corner one there. So the first pair choose alpha, the second pair choose beta, and let's say I'm the first pair. I assume that the second pair are not going to change his strategy. So if I swap to beta, we got payoff 0, right? Therefore, there's no incentive for me to switch to beta. And then like the same for the second player. If you assume that I'm not going to change strategy, I keep doing alpha, then if he changed from beta to alpha, he will get payoff from 1 to 0, right? So for him also, there's no incentive to change his strategy. So it ends up both of them will stuck there.
Yeah.
So
Okay, I
that's
get
why
Yeah.
we call it equilibrium.
So is there an easy way to find this point?
Not now. Actually, eventually, I don't know whether he will talk more, but probably not today. There's some way to find it more easily than by tracking all of them. At least you can find some candidate of them, and then you start tracking.
How to use this? Given that
I guess not exactly use, but then you know that where would be the equilibrium. And
I mean, you could predict the outcome of a particular
yes,
game.
yeah.
Like, you know, so even though you have different kind of things, right? You could then take, like, you know, so this is how, if you're competing with some other person, this is how he's going to, you know, rationalize the whole game. So we know where the game would eventually end up with, and then you could, you know, this could be used for mechanism design also. You could alter the rules of the game so as to see how much, which player gets how much, like that. So let's say that this is used in pricing, you know, pricing for various firms. You will know where the actual equilibrium prices are, for example, and then, you know, given this particular price, how would you increase your demand, or how would you know, something like that. So, we'll just do a small problem.
This is a very interesting example.
Yeah.
Okay, that's cool.
So let's call these. Let's say there are 3 candidates, right? A, B, and C. Okay, and there are 3 committee members. 1, 2, 3. Okay. And committee player 1, right, prefers A to B and B to C. So this is basically how the game is. You have 3 different players, okay? A, B, and C, and you have committee members 1, 2, and 3. Okay. So the first committee member, like, he basically prefers A to B and B to C. Okay. Committee member 2 prefers C to A to B. Did you get it?
I guess
what's that mean? A to B?
3 three people, I mean, who is competing, 3 players in the game, who are competing for the prize.
Let's give stories for this thing. Think of like you go to a firm and then like you have a search committee and you have like 3 candidates for the job. The candidates are A, B, and C, and then you have search committees like 1, 2, and 3, and then these 3 guys have some which like candidates they prefer, like for example the first committee prefer the A guy more than the B guy and prefer the B guy more than the C guy. And the second one is like C to A and A to B. And then like what's going on is like there's one guy is basically the head of the committee. And if the vote is high, then who is going to be the head? One is the head, let's say. And then if the vote is high, then basically one win. Basically, what one choose will be the candidate. So, for example, if what they choose is
let's say A candidate 1 chooses B, candidate 2 chooses A, candidate 3 chooses C, B will win.
Yes. So then the one like the player one or like committee one choose will win.
So I mean, if both choose A, right? Obviously A will win, right? Because 2 people are choosing A. But if it's tied, A, B, and C, then whoever candidate 1 chooses would basically win. Okay?
So then the interesting part is basically you think the head has more power, right? So the one is more favorable should be the one, yes, the stories go on.
So we basically, have to predict the outcome of the game. Okay, so who's going to win the actual prize? Okay, and we'll first start with considering, obviously there needs to be some payoffs, right, for every time. So we'll just define the payoffs first. So A, B, C. So what do you think the payoffs would be for, this is committee member 1. So okay, let's say he chooses, he prefers C to be the least, right? So C would be 0, right? Okay. So this would be 1, 2, right? Do you get it?
Yeah, do they vote independently?
Yeah.
So, in this case, I got this one, but I have some other questions not related to what we are talking about.
Okay. So, in the same way, right? So, what would 2 things for A?
B0.
B is 0?
Yeah.
Okay. So, for A?
A1.
Yeah.
C2.
Okay, for 3?
A0. C1. B2.
Okay.
But you said the reviewer one has more power, so.
Yeah, but this is
In both sides.
this is when for the final outcome of the game. But this is how each payoff would be there, right? The final outcome of the game, if it's tied, then winner 1 has a higher payoff. But to see if it's tied or not, right? This is how it's set up initially, right? So initially they don't, they're all the same. Only when there's a tie, right? Committee member 1 has a higher say. So, okay, let's start with, let's say player 1 chooses A, okay? So, So what would be the outcome of the game when player 1 chooses A?
Sorry, I missed.
I'm sorry. So when player 1 chooses A, player 2 chooses A, and player 3 chooses A, what would be the outcome of the game? A, right? Right, and
Can you say again?
huh?
Can you say again?
So player 1 chooses A, player 2 chooses A, 3 also chooses A.
Oh, yeah.
So all 3 choose A. So A is the A is going to be the winner in this case. So when player 1 chooses A, player 2 chooses A. A. So do you want to complete the matrix? Like just A, B, A, it's A again,
Yes.
right?
But B.
A, B, C. A. So this is
A.
C.
Yeah.
Okay. So you want to do it? So I'll just you want to do it? I'll just write everything down then. Okay. So this is A, C, C. Right. Just correct me if I'm wrong. I could be wrong. Okay. So this is like how the game will be played when the strategy for player 1 is fixed. Okay. And we will do the same thing with player 2 being fixed and player 3 being fixed here. Okay. But before that, right? Let's see what this particular payoff matrix would look like. Okay. So this would be like this would be what according to A. What is A? 2, right? This is the game according to A. Player A's strategy is fixed, right? So this is 2. What is B?
1, 0.
Here. Sorry.
Yeah.
So what is this then? This is you want me to take this off? I could take this off, right? This is according to B and this is according to C. Okay. So B chooses A. I'm sorry. I keep getting confused with these things. 2 chooses A. Sorry. 2 chooses A and
3 chooses A.
I'm sorry. 3 chooses A. 3 chooses B. 3 chooses C. Does anybody want me to help? Want to help me with that payoff matrix?
Yes, yes.
Okay. Okay. VAA. Right? VAA. So it's A, right?
Yeah.
This is B, right?
Yeah.
No.
It's player 1, player
Yeah.
2,
Yeah.
it's B.
Player 1 chooses B. Player 2 chooses C.
It's B.
Yeah.
A.
Sure, I'm not sure this matrix needed. This is that you I don't know how you want to continue, but
Yeah. I mean, I could.
yeah.
Oh yeah, I'll just. continue.
I think like you don't really need to draw those matrices because you
Okay,
can see like
I mean, from here we can take out a couple of matrices, right? Is that what you're saying?
yeah.
I mean, we can just say A is the choice, but let me just explain that.
Okay.
Yeah. A is equal to 0, B is equal to 2, C is equal to 1. B is equal to 2. B equal to 2. C is equal to 1. So these, thanks. So these were the total payoff matrix that we derived. So let's say that I claim that player 1, right, would choose A over B and C. So can you understand why? Would always choose A over B and C. Because I also claim that it's a dominating strategy when compared to B and C. So for any value of this particular thing, yeah, you're right.
It's larger than.
Yeah, it's larger than any of these two. So let's say like 2, 2, 2, 1. So this you have to look at this as a whole strategy, right? So this you wouldn't pick this, or you wouldn't pick this. You would pick only this if you are player 1, because totally it gives you a higher payoff than B and C.
Yeah.
Okay, so now you're in player 2's shoes now. Okay, so you know that player 1 is only going to choose A. Okay, so now you go with this here. So what do you think is the this thing? Player 1 is
C.
Yes.
C.
Yes.
C, I think.
yeah, right? So you're going to choose C now, and then
B.
you could choose C, or you could choose this particular thing, right?
C is better.
C is better.
Because C has a tree.
Yeah.
It's called weak dominating.
Sorry.
It's called weakly dominating.
Yeah. So which one? So which one do you think is?
I think C, because C
Yeah.
is 2, 1, 1, but
So okay, let's start with this. Is no way down. Okay,
Yeah.
this is no way taken, right? So okay, okay. Okay, so let's two picks C here, okay, and so 3, right, will either now 1 is going to pick A, 2 is going to pick C, right? So 3, right, has either the option of picking B or C. I mean, right? Let's say he A, B, or C, right? So but what is his choices then? Right? I mean, he prefers
Yeah.
C to A, right?
Yeah.
So if he picks A, he knows that A is going to win in this particular case,
yeah.
right? And so he cannot pick B also, right? Because if he picks B, then 1 goes to A, 2 goes to C, 3 goes to B, and then again A wins, right? So, but he prefers C to A.
Yeah.
So he also picks C in this particular case. So the eventual winner would be C here. So basically, when we think that A has a big advantage here, right?
Player 1.
I'm sorry, player 1 has a big advantage here, right? We see that the last outcome is like C.
So if they given 3, reverse 3, the reverse 1 will choose A, so then how to play this game? I mean, change the order of reverse.
No, it's okay. It's not order. It's just you're thinking about what the other player does before you take your decision.
Yeah, in this case, you give the information.
It should be the same, no matter what the order of the game is being played. So actually the knowledge, right, that came out of this particular matrix is player 1 is going to choose A no matter what.
Suppose player 3 knows player 1 will choose A, then what was the outcome of pair 3?
It doesn't
Okay,
matter,
so-
look at that first one. Even though like pair 1 knows that like eventually pair 2 and pair 3 will choose C, right? But what can he do?
Not.
No, nothing.
Yeah.
No matter what he chooses, he'll get 0.
Yeah.
Yeah.
I mean,
You look at that one, like the first plot here. I know the pair 2 and pair 3 is going to choose C, so I'm only considering here, right? This one, and this one. For him, he has nothing to do. No matter what he chooses, he'll always get 0.
Yeah.
So I mean the moral of this story is really interesting. Well, yeah, is that like you think pair 1 has advantage from the rule, but turns out the one his least favorite will be chosen.
I mean, if player 3 knows player 1 will choose A, then player 3 can choose B or C, right?
Which one?
If player 3 knows that player 1 will choose A,
Yeah.
then he can choose B or C, right?
No.
No, it doesn't matter. You just look at this one again. Let's say pair 1 choose A.
Yeah,
Pair 1 choose A. You can look at this again, right?
yes.
Pair 1 choose A, then basically you're looking at these 3 choices for
What's the
pair
best
3, right?
choice?
It's still like.
Anyway, he's not going to choose A, he's just going to choose between B and C. Right? He
Yeah,
still has a choice
because
between B and C.
He prefer B then.
I'm not sure this number is correct. I think it should be.
Yeah, I think he can choose B and C. But given that, you know, he would basically prefer if, so let's say,
for player 3, he choose B, he will got the most.
No, but if he choose B, the player 2 choose C, and
player 1 chooses A, right?
A and
A
player 1 must be winner, and because of this, player 3 must choose C instead of B.
So, okay, let's go through this again. From here, B and C can be chosen, right? I mean, do you get that?
Why?
No, because look, so he knows player 1 is going to choose A, right?
Yeah, yes.
Okay, so he goes with this this one, right? So in any case, he's not going to choose A.
Yeah.
So he can choose between B and C, and there's nothing dominating,
Yeah.
right? So it's a toss-up between B and C here. Do you get that?
Yeah, and then he consider pair 2 voice.
Yeah. Now he comes here.
Yeah.
Player 2 will, like we said, player 2 will always choose C. No matter how it's played. Do you get that?
Yeah. How to define the dominating? I mean, for
Here?
player
Here?
3, if he choose B, he will got the highest.
No. Okay. So look, we are
Because
under
he
the.
prefer B and B has the most payoff.
I'm sorry.
Because player 3 prefer B, right?
Yeah.
But why not he choose B?
Okay. So if he chooses B,
Yeah.
what's the final outcome of the game? Anyway, he's not. It's going to be his least preferred choice. If he can choose B and C here, okay. The player chooses A here. This guy chooses C here. He chooses B. Let's say he goes with his own this thing. He chooses B here. Okay. So we have B, C, and A. What's the outcome of the game? A, right?
Yeah.
So if you have algorithm to compute this, say you have 100 like committee member, so you have to go through each of them and fix the vote for that committee member, which who has dominating strategy. If he has not, like
If he doesn't have that, then
he will just wait for the rest of the committee members.
yeah, it's called iterative deletion. This is called iterative deletion. Iterative deletion. So iteratively delete your strategies, seeing like how the game shapes up, and that's another thing. I mean, I actually wanted to discuss that one also.
Okay.
So,
In this case, because this guy has no dominating strategy, so he has to wait for other
to
guys
see how
who
the
has,
yeah.
Okay.
But it's not like waiting. I mean, he keeps in mind like the different moves. It's like, you know, it's like chess, right? So okay, so what if, you know, you make this particular move? He'll make like he can make 3-4 moves, and then, you know, like it's like that. So but the game by itself is being played only once. There's just one play. You're done. But you can think of all possible outcomes and then choose which one is best for you. It's a game like with complete information. You know what all the possible strategies are, all possible outcomes and all that. Okay. Okay.